A polynomial isn't simply an expression that has many terms. There are some special polynomials that you've probably heard of. A polynomial that just has one term is called a monomial. A polynomial with two terms is called a binomial. And then something that has three terms is called a trinomial. And those are all special expressions that we are going to deal with throughout this course. But when we move past three terms, we can just generalize them as polynomials. There are a couple things that you need to be able to identify with polynomials. You need to be able to identify the coefficients, which are the numbers out front. You need to be able to identify the degree, and the degree here is the exponent. And when there's only one term, it's simply the exponent of that term. But if you have something like 3x squared minus 4x to the fifth y to the first, you have to determine the degree of each term. The degree of this term is 2. The degree of this term is 6, and you get that by adding the exponents together. So this polynomial would be considered 6th degree. It's typical to write a polynomial in what we call descending order. So this typical polynomial would be rewritten as negative 4x to the fifth y plus 3x squared, and we would consider our leading coefficient to be negative 4. It's important to be able to recognize things that are not polynomials. So for example, x cubed plus 2x minus 7x to the negative 1 is not a polynomial because in a polynomial, all of the exponents must be non-negative integers. And do note that they do have to be integers. They can't be fractions. So radicals keep something from being a polynomial. However, don't let something like perhaps 3x to the 0, which is just thought of as 3, throw you off. This is a polynomial. It's just of 0 degree. You need to be able to perform basic operations with polynomials, which include things like addition and subtraction, multiplication and division. We'll deal with division completely separately. But with addition and subtraction, you're dealing simply with combining like terms. So for example, if I have an expression like this, where I am subtracting two polynomials, notice the first thing I'm going to do is distribute this negative sign to both terms. I end up with 4ab cubed minus b cubed c minus 4 plus b cubed c. The two like terms exist here. They cancel each other. These are not like terms, and so I leave this as 4ab cubed minus 4, which we will get into later how we can factor to simplify slightly. You do need to be able to multiply polynomials, or in this case, two binomials. For example, if I have 2x squared y minus z cubed times 4 plus 3z. I'm multiplying two binomials. And don't forget the term FOIL. We're going to do first terms, which gives us 8x squared y, outside, which gives us plus 6x squared y z, inside, which gives us minus 4z cubed, and last, which gives us minus 3z to the fourth. It is always important to check for like terms after you multiply two binomials, but in this case, we do not have any like terms, and so this will stay as is. Do not let something like this throw you off, x minus 4 squared. Please note that that is just going to become two binomials times each other, which we will then again FOIL.